I'm going to talk about three things this afternoon. First of all, what are the best treatments to produce? How low could the costs become for these treatments? And what are the implications of all of this? Now, I think for most of the other presenters, you've had a disclosure slide, and I have received in the past donations from different pharmaceutical companies, but from what you might see in the next 20 minutes, you might see why they're not funding me very much anymore. So what would you like to see from a combination of DAAs? What would you want to see in order to mass produce a treatment? So you'd want a treatment which produced consistently high SVR rates across a range of genotypes, particularly for countries where there was a diversity. So if you look, we've done a meta-analysis of all the most modern DAAs, and what I'll show you is a set of bar graphs of percent SVR versus genotype. So you can see, first of all, for soft lead, you get quite good responses for all the genotypes except for Geno 3. And then for the Merck combination, you get much more of a mixed pattern, so you get the activity in Geno 1, 3, and 4, but the results fall down for Geno 2 and 5 and 6. And then if you look at soft DAC, you get the fall in Geno 3. It's been widely described. Some people need 24 weeks of treatment or adding ribavirin. In soft VAL, you also get a slight fall in Geno 3, but it's not as pronounced as with soft DAC. And then the most recent results from the AbbVie combination, you get probably the best results so far. However, you've got to remember, these so far are phase 2 and phase 3 trial results, and when we get more data in real-life populations, maybe those SVR rates will go down. So we have some candidates, and certainly sofosbuvir declatosphere is being mass-produced by companies in India, China, Bangladesh, Egypt, Algeria, South America, all over the world. There are companies producing that treatment, also soft lead to a lesser extent. How cheaply can medicines be produced? Now, I have a team of 10 people, and they're like these detectives. They're looking for drugs being exported and imported from and to countries. How much does a kilo of the API, the active pharmaceutical ingredient, cost? So we have people analyzing databases of imported and exported drugs from India and from other countries. So we can see kilograms and quantities of these drugs being brought to and from various countries. So, for example, this graph on the y-axis is the cost for a kilogram of sofosbuvir, and on the x-axis is time. And you can see just over the last 18 months, a massive reduction in the cost to make a kilogram of sofosbuvir from around $9,000 in January of last year to just over $1,000 at the end of this year. Now, it's even going lower than that. I'll show you a bit later how, when this drug comes out of China, it's even cheaper than this. But if you just take this price, which we presented at the World AIDS Conference in Durban, and then more recently at AASLD, we have an equation which we validated for HIV and for tuberculosis, where you take the cost of a kilogram of drug, you work out how many grams somebody needs to fill a treatment course, say for 12 weeks, and then you add on costs for the extra ingredients and the tableting, the formulation, and then you can add in a profit margin. The profit margin can be whatever you want. For HIV, it's around 10%, but you could make it more generous for hepatitis C because this is more of an emerging field of treatment. So if you just take the example of sofosbuvir, assuming this cost of API of just over $1,000 per kilo, so one person for 12 weeks needs 34 grams of sofosbuvir. Now that raw drug, if you just take the treatment being exported from India, costs $37. You then have to formulate it. So you've got the cost of the excipients, the cost of tableting, packaging, etc., which takes you to $40, and then up to $41 with the final packaging, and then a profit margin, if you say here it's 50%, you get to a price of $62 to make a 12-week course of sofosbuvir. Now, we've applied the same equations looking at exports of these drugs from India to other countries. We actually predicted in July 2013 that sofosbuvir was going to cost between $68 and $136, and that declatosphere was going to cost between $10 and $30 per treatment course. And for once in my research career, I've got something right. It actually did turn out to be that number, which was quite reassuring. If you then look at the cost of or the price of these treatments in various countries versus the cost, if you look, say, at Germany or France or the UK or Canada. Now remember, these are list prices, and there will be discounts below these prices in some countries, although not necessarily in all. You can see that the treatments are being sold for up to 1,000 times what they cost to make. And that's true of sofosbuvir, declatosphere, across the range of treatments, a 1,000-fold markup. There's one outlier here. You can see that Australia has a unit price at the moment of 3,400 euros per course of treatment. Now, that's not the actual list price. That's the result of a negotiation they've made with all the pharmaceutical companies making hepatitis C treatments, that they would pay $1 billion Australian dollars over 5 years, and then they would be able to treat as many people as they wanted. This year, they have spent in the region of 138 million euros, and they will treat in the region of 40,000 people. So the unit cost of treatment at the moment in Australia, given that it's potentially changeable over time, is in the region of 3,400 euros, which is significantly lower than any country in Europe and far lower than the US price. So if you then look at the production prices of all of the main direct acting antivirals, you can see that sofosbuvir is $62. Declatosphere is a lower dose. It's 60 milligrams a day. It's intrinsically an easier drug to make. You can make declatosphere according to these target prices for about $14 US per 12-week treatment course. Soft lead, $96. Soft val between $181 and $216. Now remember how quickly these treatments are falling in their prices of production. We can see in India, we're getting prices well underneath the original $900 estimate from Gilead when the drugs were first put into voluntary licenses. So the price of sofosbuvir has already fallen to $324 in India, declatosphere $153. Sofosbuvir valpatisvir is now being exported from Bangladesh for $300 per month as a single co-formulated tablet. So that's already going down. And actually, this field is moving so quickly. Even since I produced these slides, I had to put in another one because we found now that sofosbuvir and declatosphere API is being exported from China for $800 US per kilo, as opposed to almost $1,100. What happens is it's exported from China to India and then re-exported from India to other countries with a 20% markup. So given that, we're in our next presentation, we're going to show that the production price of SOFDAC has now gone down to $55 US as a combined treatment for 12 weeks. And in Egypt, according to the most recent WHO report, sofosbuvir declatosphere is now available for $172 per 12-week treatment course, which is lower than the prices in India. So the price of production of these treatments is becoming trivial, and it makes you wonder in your own country, if the treatment was anywhere near this low price, how would it affect your national hepatitis C policy? All the barriers that we've heard about with Medicaid not allowing people to take treatments if they are recent alcohol users or drug users, or if they have the wrong stage of liver disease, would those barriers disappear if the price of treatment fell significantly? It's not just hepatitis C. This photograph shows the amount of entecavir you need to treat somebody for a year. The dose of entecavir is 0.5 milligram per day. So for a year, you need just under 1/5 of a gram. And there it is. That's the powder next to a matchstick. Now, the cost of entecavir production is so small that it actually costs more to make it into tablets and package it and label it and the excipients than the drug itself. Entecavir can be made for $36 US per year, and there are actually factories being set up now to mass produce entecavir. The patent has expired in the US, many other countries it's due to expire in Europe throughout 2017. So this is a drug being sold in the United States from Bristol Myers for over $15,000 per person per year, and it can be made for 36. So this multiplier of 100 times or 1,000 times cost of production is true for hepatitis B as well as hepatitis C. If we look at the target prices that we calculated versus the actual prices, how valid is our algorithm? So on the y-axis, you have the target price of treatment based on API exports, and on the x-axis, you have the global lowest price. So we can see that treatments for HIV and for tuberculosis are already being made at close to these target prices. In some cases, we actually overestimate the cost of production when we look at our API-based prices. But you can see on the right here, you have the current prices of entecavir, soft DAC and soft lead in India, and we expect over the next year for soft lead, soft DAC, entecavir all to fall on the line of correlation at very close to the target price, provided that volumes can be guaranteed. So when people talk about 90, 90, 90 for HIV, diagnosing, treating, suppressing at least 90% of people, we believe there's a $90 target price for a year's treatment for HIV, a treatment course of 12 weeks of DAAs to cure hepatitis, a year's treatment for hepatitis C, and also first-line TB treatment. It's all doable, and we can actually see the medicines being produced at that cost at the moment. So one question that will immediately come back. Now, these pharmaceutical companies, could they just do this? I mean, why are they not treating more people for a lower fixed price? It's a classic economic story of volume versus margin. You increase the volume and you decrease the margin. And I think we can already see, as I said, with Australia, this concept of all-you-can-treat pricing. You have a fixed price for a country for a year, and you treat as many people as you can. It has been achieved in Australia, so it could be achieved elsewhere. The other issue that comes up is, how could a pharmaceutical do this and actually afford research and development in the future? If they were almost giving away their drugs, would their pipeline shut down? Now, if you look at the amount of profit that Gilead have already made, the amount of sales that they've made in the last 3 years from hepatitis C drugs, if you add up the global sales of Sovaldi and Harvoni up to just the third quarter of 2016. Remember, this is increasing all the time. Already it's $40 billion. Now that has easily repaid the cost of research and development. And remember, the patents for sofosbuvir and ladipasvir and the other drugs will continue at least for another 13 years, even excluding secondary patents. The profit last year alone was $18 billion. So I think this argument that we have to pay high prices in order to fund research and development, it's just invalid. In fact, it goes even further than that. If you look at the amount of money that pharmaceutical companies have in foreign territories, the intellectual property for the hepatitis C drugs is held in Ireland, and there was an investigation recently published in the Washington Post showing that Gilead has managed to avoid $10 billion in taxes by keeping its intellectual property and its profits offshore out of the United States. Now, with the costs that I presented to you before and the size of the hepatitis C epidemic worldwide, just that tax avoidance money, just the $10 billion, is enough to treat everybody with hepatitis C worldwide. And it's not just Gilead. If you look across the range of pharmaceutical companies, Pfizer, $69 billion held in the Cayman Islands or the Bahamas or territories like that, avoiding $20 billion in tax. Merck, $57 billion held offshore. Johnson & Johnson, Amgen, Abbott, Bristol Myers, the list goes on. So this idea that we have to have these huge prices to avoid pharmaceutical development stopping, it's just a fallacy. So what do you do in a situation where the drugs are still patented? How do you get access to these drugs? Some companies will say, well, we have voluntary licenses. We allow the drugs to get into countries, and we'll allow low-cost production. And I think to some extent that's worked very well for HIV. We do have antiretrovirals getting into a wide range of countries at low prices. But we've got to remember, there are countries that have significant disease burden, significant epidemics that are not included. So for hepatitis C, China, South America, Russia, most of Eastern Europe are not included in voluntary licenses, so they cannot take advantage of these deals. I went to Moscow recently, and the cost of sofosbuvir declatosvir was $15,000 for 12 weeks of treatment, completely unaffordable and not reimbursed by the Russian government. Other countries have voluntary licenses, but if the company doesn't register the drug for sale in that country, for use in that country, it can't be used. Bristol Myers have not registered declatosvir in many countries with key hepatitis C epidemics. And so far, I'd like to hear from the companies, but I'm not aware of voluntary licensing agreements from all the other companies. What about Merck? What about AbbVie? What about Janssen? The other companies producing the hepatitis C products. If you just look at Gilead and sofosbuvir, in green are the countries which have benefited from voluntary licensing. So these are countries where the voluntary license applies and where the company has successfully registered the drug. So you can see it's actually a very small number of countries that can take advantage of these voluntary licenses, and we need much greater efforts, not just from Gilead, but from all of the pharmaceutical companies, to make sure that these voluntary licenses are introduced and rigorously applied across the range of countries. So the other option for people who simply can't get access, we have people in the UK who are told, you cannot be treated, we can't afford it, the price is too high, you're going to have to wait a year, you're going to have to wait 2 years. And people have this very difficult choice. Do I simply wait with my hepatitis C as it is? They might infect somebody else, they might get HCC, they might get liver cirrhosis, or do they decide to go through what's called a buyer's club, where in the UK you can legally import the drug for your personal use, and various websites down there. You could go on your phone right now, you could order sofosbuvir to import it into the UK in 5 minutes using your credit card. It's very simple. So we did a program with British Television, with BBC Newsnight. We also did one with Channel 4 where people talked about their experiences of importing the drug for their personal use. We had a guy called Sean who'd gone to Australia, got sofosbuvir declatosvir, he was cured. Another woman, Kate, who'd been treated in Germany, 45,000 euros for the same treatment. It is legal for UK citizens, Australian citizens, a variety of other countries to bring the drugs into their country for their personal use. You need to check which country you live in and where the laws apply, but these medicines are being sent all over the world. I'll just show you a few examples. So my research team looks at buyers clubs. This is Fix Hep C, run out of Australia, and these are all the different sites around the world where people have imported. A lot of people are getting the drug into the United States, into Canada, it's going into Africa, across Europe, and the SVR4 rate, which we presented in Glasgow, is 89%. Remembering that some of these people are really in difficult situations. They could be Geno3 cirrhotic, and still we're getting quite high cure rates. This is hepatitis C treatment without borders, run out of Australia. Again, 96% SVR12 rate. These groups are treating thousands of people, and we've just done a sub-study of the few people who have answered the questionnaires. This is the Southeast Asian Buyers Club, run through the American Foundation for AIDS Research, and SVR12 of 92%. And then finally, the Russian Buyers Club, they have 5,000 people treated through this Buyers Club. They have a parallel Buyers Club treating about 4,000, and this is just growing exponentially. This time last year, there was hardly anybody being treated in this way, and this is almost grown out of nothing. And I'm hearing about more and more of these Buyers Clubs, because what else are you going to do? If your health authority says you can't be treated, this is their only option. So just to conclude, these drugs are fundamentally very, very cheap to produce. This is like HIV 17 years ago, where people said, we can't treat Africa because the treatments are too expensive. And then the generic companies said, well, actually, it costs $1 a day. And remember the predictions that generic companies made back in 2000, that HIV would be treatable for $1 a day. They were overestimates, and now the cost of HIV treatment is down to below $100 a year. I think actually, looking back on the results we presented in 2013, we overestimated the production price of treatment. I can see it coming down to about $50 to cure hepatitis C with soft DAC in the very near future. So we need new approaches to funding mass treatment programs. We know that the drugs are fundamentally cheap. or either all-you-can-treat pricing. We need lower fixed prices. There's no reason that the treatment should be more than 4,000 euros per person in Europe if the Australians can get that deal. Remember, these drugs are so cheap to produce that a company can make a large amount of money from treating more people rather than at the moment treating a smaller number of people with a higher profit margin. And if we get into the situation where companies refuse to lower prices, we need different mechanisms to ensure access to treatment. Compulsory licensing, which is a legal mechanism for a country in a public health emergency to get access to a treatment. It has been used before, it could be used in the future. Buyers clubs are being used, and even windfall taxes. So don't forget, the amount of money avoided in tax from Gilead, $10 billion, is enough to treat everybody with hepatitis C worldwide. Thank you very much.
Thanks very much for this presentation. Just a small correction. Now the Egyptian pound has been devalued a month ago, so the price of a full course of treatment is less than $80.
$80, okay.
Yeah, less than $80 actually. so that's a small correction. My question is, how much extra is needed to produce pediatric formulations? We have trouble, for example, to access entecavir syrup for children, and I wonder if this adds a lot to the price. Companies decline from doing any pediatric investigational trials because of the production price of pediatric formulations. So I need your...
So our experience so far is it's the cost of the raw drug, the API, that drives most of the treatment cost. And once you've covered that, the cost of formulations is not so significant. I think, you know, if there was going to be a particular campaign to produce pediatric forms of entecavir, that would need its own funding mechanism. But it can be done. And it has been done for HIV. There are many examples of generic companies taking up the production of pediatric forms of various antiretrovirals and producing them at scale. So I think it can be done.
Very interesting. What it also shows is that you need government involvement too, right? Because if you compare the Australian setting to a Russian setting, what's different here is different political systems and different governments. So
I mean, you look,
in the long term,
yeah.
I'm worried, but I like the concept of people who are in great need to organize their own health. On population level, you need more than that, right?
So I think the buyers clubs have shown that the generics work. The Egyptians have shown that these drugs can be produced very cheaply and treat large numbers of people. But I completely agree. You have to have government involvement. I mean, without the blessing of the Egyptian Ministry of Health, it would never have been possible to treat that number of people. And you're right, the Russians don't have that level of support. So, yeah, you need various things to come into play.
Yes, I'm probably coming from the country which pays the most, Norway. So we paid $90,000 for soft duck.
90,000? Wow.
So that's our reality, and one of the reasons is that our government has said it's willing to pay for value of the drugs, and that is the value of the drugs around. It's still cost effective, and what's your response to that? Is that the way we're going to price in the future, new interventions?
Well, two things. I sent comments to NICE about the cost-effectiveness model, which would be the same one that you had, and there are lots of flaws with it. I mean, for example, it's completely unrealistic in that it only assumes people are treated once. They're never treated again. I mean, you could have a situation where people are treated first with a cheaper drug and then second with a more expensive drug. You could have the introduction of generics during the lifetime of the treatment. So I wouldn't believe, if a company says this treatment is cost-effective, the actual cost-effectiveness models are very flawed. The lifetime extrapolation is such, it requires so many assumptions, it's very hard to work on it. So I think that would be my main, and you need to push back. The other thing is, even if something is value, it's not necessarily affordable. The cost of treating everybody in the United States for hepatitis C would just destroy the health budgets. So there's a big difference between cost effectiveness and budget impact, and I think we've hit budget impact with hepatitis C very clearly, and I don't believe the drugs are cost effective at their current prices.
Okay, so then, thank you very much.